Welcome, sir.
Yes.
It's time to start something new and trust the magic of beginnings. Good afternoon, one and all present here. On behalf of the management, correspondent, principal, and faculty members of ECE, EEE, and VLSI, SA Engineering College, we extend a warm greeting to all. SA Engineering College offers a student an advantageous atmosphere with state-of-the-art facilities, distinguished mentors, and a pleasant educational environment. The institution provides the employability and communication skills for the development of students. It provides quality education in an environment of discipline. The focus is on shaping students to become self-disciplined, self-dependent, and self-confident individuals. The Department of Electronics and Communication Engineering offers BE degree program in ECE, ME degree program in Communication Systems, and PhD degree program. The department is dedicated to academic excellence, innovation, and research. The Department of Electrical and Electronic Engineering offers BE degree program in EEE, ME degree program in Embedded System Technology, and PhD degree program. The department is supported by a team of dedicated and highly qualified faculty members with expertise across various domains of EEE. The Department of Electronics Engineering, VLSI Design and Technology offers a BE degree program in VLSI to prepare professionals for successful careers in the semiconductor industry. The program emphasizes interdisciplinary skills, encourages research and innovation, and provides extensive hands-on experience. Today's event, LaunchPad 2026, Kickstarting B.E. Beginnings organized by SA Engineering College in association with ECE, EEE, and VLSI. The topic is Charge Up Your Future, Exploring Electric Vehicles and Emerging Career Opportunities. It gives me great pleasure to welcome all the faculties, participants, and our guest of this event, Mr. SREERAJ SV, Director, Technicals and Operations, EmCog Solutions. Let me give a short introduction of our guest to the participants. Mr. SREERAJ has completed his ME Power Electronics and Drives under Anna University, and he is a university rank holder. Currently, he holds 3 different positions in his career. He is the Director of Technical and Operations, EmCog Solutions, a program mentor for executive PG certificate programs in electric vehicle course certified by IIT Roorkee, and also a franchise partner, Ansett Consulting. Previously, he has worked as an assistant professor in Sri Venkateswara College of Engineering, also as a development engineer in Top Systems Private Limited. and he has started his career as a design engineer in Honeywell Automation India Limited. His projects mainly focuses on electric vehicles, power electronics, design and analysis. His clients are from IIT Madras, CBRDE, ARI, educational and R&D organizations. Welcome, sir.
Yeah,
now, I request our guest to start the session with his presentation.
Yes, thank you. Thank you so much, ma'am, for your warm welcome. So let me share my screen.
Yes, sir. Thank you.
Yeah. Fine. So I hope you can see the screen. The screen is visible to you.
Yes, sir.
Yes. Yeah. Right. So today I'm going to give you some idea about what are the different technologies which is much focused in electric vehicle, and what what is the contribution of Indian engineers, Indian entrepreneurs, especially in this EV ecosystem. So that's what we are going to see today. And before we enter into what are the emerging careers, and rather I'll try to give you some idea about what are the different technologies, different domains which we work, especially in electric vehicle. So let me show you a few of the systems so that you will understand what India is contributing towards electric vehicle. So I'm going to discuss about these 8 systems today, which carries different domain specific knowledge. Okay, and especially in mechanical design, electrical design, then electronics, then embedded, then IoT technology, then AI and ML. Okay, so that is what mainly these are the specific domains which we apply into electric vehicle. First, I'll take you to different systems, whatever I've shown 8 different products, so that you'll understand what is the real specific application each technology has contributed. So here, the first one I'll be explaining about electric two-wheel powertrain system. So basically, in India, you all know that electric vehicle is an emerging technology, and people have focusing more into green energy, green propulsions, and so on. And we have very big Indian companies. If you look at Ather or Ola, they are completely Indian companies which focuses on developing e-scooters. And also, if you look at the 3-wheeler segment and 4-wheeler segment, also India has contributed much towards all these emerging technologies. Now, the second thing, this is one part of vehicle design. Okay, so in vehicle design, so we have more specific careers in terms of mechanical design. Mechanical means mechanical chassis design, then mechanical body parts, right? So all these comes into mechanical design. So apart from, in order to build a vehicle, obviously you need motors, right? You need motor controllers which gives energy to the motor, and then you also need battery, correct? So battery, generally if you look at some 10 years back and all, we'll try to import battery from other countries, but today India is making our own battery packs. Even the raw materials also we try to generate from the country itself. Now, if you look at the second system, which is called battery pack and BMS testing. So this basically is a technology where we much focus on how to make a battery pack. Okay, so the first part will focus on making a vehicle. Okay, India has contributed very much significantly in developing vehicle chassis, as I said, vehicle chassis, motor, all these steps. And then we have emerging technology in battery pack and BMS testing. Means that the batteries which we use in electric vehicle is not something, an ordinary battery which we try to use for our inverter or any other applications. These are some very critical segment, because these batteries are very high energy batteries. So for example, a single cell, okay, a single cell can give you 100 amps. A single cell can give you 100 amps. Also we have single cell which can give you 200 amps also. See, that much of huge amount of energy is contained inside single cell, which is of very small form factor. So now dealing with how to, when we make the battery pack, then we have to be, we should take very much care in making this battery pack. So it's a very critical segment. So we have a great opportunity in making the battery pack of different variants. As I said, maybe 1 ampere battery pack or even 1000 ampere battery pack also. And this technology is going to rule another segment also in very, very soon. So for example, you all know that we have inverters at home. I think most of the, wherever electricity is there, around 40 to 50% of the home have inverters also. An inverter, we use normal lead acid battery, which is very huge size, and you need to do a lot of maintenance also. And if you take any industry or in institutional segment also, they use UPS and they use battery packs as power backup. Now, these battery packs, which is conventionally used in institutions or maybe in industries, going to be replaced by these new battery packs, which is made up of lithium chemistry. So currently we use lithium chemistries of different variants like lithium NMC, nickel manganese cobalt, and then we use lithium ferrophosphate, LFP. So different variants of lithium is actually ruling the energy storage segment. That is not only even in electric vehicle. These chemistries actually focus more into other battery storage applications, such as industrial applications, as well as the power backup applications also. And even if you look at drone, so drone is very common these days, right? So different capacities of drone being used. So in this drone also you have battery packs, right? So these battery packs also made up of the same chemistry, which is lithium NMC or lithium iron phosphate. So India has very huge amount of space. As an electrical engineer or electronics engineer, we do have a very huge space for the next 10 years to rule the energy segment. Because energy is something which is inevitable, right? You see, you cannot imagine a day without energy. Without electricity, nothing can be done, right? So wherever we have already set up the battery packs using the previous technologies like lead acid technology, so these are going to be replaced very soon with lithium. So see, the around 40% of the population who uses uses electricity are using inverters or power backup applications also. So we have a very huge space in serving those population as well. So if you look at the length and width of the energy space in India, it's very, very huge. And that's the reason you have recently have seen there is a tremendous amount of investments and focus which is given or which is made by the central government and state government to boost the energy segment of the country. So in that way, if you look at very carefully, there's a huge career opportunity which is going to come. And another one is in India, we have something called testing. If you look at many of the IT applications, or if you look at some 20 years back, we do have greater opportunity in IT segments, IT and CSE. So basically, in IT, what we do, we try to do most of our job role will be like testing, right? So India is a very huge hub, okay, in giving testing support to the world. So if you look at any technology, since our we have a very huge amount of human population and a good competency. So Indians are, being involved in the testing areas everywhere. So if you look at in EV also, we have a greater opportunity in doing testing of battery packs, testing of EV systems, and so on. Why testing is very important? Because if you look at recently you would have seen Ola has some issues in the battery packs of Ola, and so many problems around the circle. So why these have happened? Because India is new to EV technology. Even there is a body called ARRAY, Automotive Research Authority of India. They do test the vehicle before they release the vehicle to the market. Since India is actually an emerging country in EV technology, we don't have sufficient competency or sufficient rules to bring into that channel to test any vehicle with stringent condition before they go on road. So currently we know what are the different problems coming in vehicle and how to do stringent testing before the vehicle is released on road. So those areas are very, so that's the reason today you could see many instruments. So whatever you have seen maybe in 20 years back or 10 years back, maybe the testing of any system, we have some limited resources. But today we have n number of resources, n number of equipments being developed to test different electronics for different applications. So that is the huge area where India is focusing, testing. Okay, because we normally have the habit to import raw materials from other country. We never buy a product, because when you buy product, then the import cost is very huge. Then you have to pay tax in addition to import duty as well. So that's not competitive in the market. So what we normally do, we try to import only the raw materials in the worst case, and once we make the system here, we do the testing. So India has a very huge opportunity in going for electronics testing for electric vehicle. And the next technology is very, very important technology, which is called IoT. So hope everyone would have gone through this particular technology called IoT. So IoT means Internet of Things. So Internet of Things means anything which you can control or which you can monitor remotely. So assume that today we have a very huge market in transportation, like a Rapido have come. Okay, we call it as fleet services. So under fleet services, we have Rapido, we have Ola, we have Uber, and so many things. And in addition to these big chains, we also have local fleet services managed by local people. Now think that if you have 10 vehicles or 100 vehicles or 1,000 vehicles, and you give it for rental, okay, and you wanted to monitor how the vehicle is being driven by your driver, okay, and you cannot call that person, that driver, every time and see where are you, or you cannot check what is the pattern of his driving, how he handles the vehicle, how he applies the throttle, how he applies the brake, what speed he maintains. So all these things you'll not be able to monitor when you try to expand your business, right? So this particular technology, which is called Internet of Things, we can apply this technology. We are still applying this technology to remotely monitor the performance of your services. Means that, let's say you do have 100 vehicles, 100 cars, and you have rented out with 100 drivers. and you wanted to monitor what is the average speed the driver is driving, or if any accident comes, is it the mistake from your driver or from the third party? And you also wanted to see how the vehicle parameters are maintained, whether the driver, for example, if it is an EV vehicle, whether he does the charging properly, okay, whether he goes beyond the speed limits, whether he handles the brake system properly, or he is giving sudden brake and so on, whether your other electronics and the HVAC system, heating, ventilation, air conditioning system in your vehicle is being used properly. For example, he may give he may not maintain or clean the HVAC system as well. So all these things you don't want to go and talk to your driver, right? And you can monitor by remotely sitting at your office. So this is possible because of this technology called IoT. And in addition, if you're able to add a little more leverage or little more knowledge into it, okay, little more knowledge in the sense that something called prediction. So for example, you wanted to say that, or you wanted to predict that when you have to do the next maintenance, right? So why we have to predict it? Because if you predict it, you will be able to reduce, or you will be able to ignore the breakdown of vehicles. So for example, if somebody is driving a vehicle and let's say the battery is going to drain, okay, and once drained, you cannot search for a charging station, okay. This is one problem. Second problem, let's say consistently you are using a vehicle, okay, and you could see that there is some problem, the vehicle is not giving you mileage, okay. So you cannot still, okay, take it as granted and drive it. That is not possible. So here, if you are able to apply one more higher level of knowledge, you can do prediction, saying that, okay, so what is to be maintained, okay, something to avoid the breakdown, we need to do some kind of maintenance. So what maintenance or which parameter is actually degrading, accordingly we can try to apply the or do the maintenance as well. So this is one thing. And second thing, if you add one more layer, it's second layer of knowledge, okay. The first layer of knowledge upon IoT, you can predict maintenance, but apart from that, okay, second layer, if you're able to apply through artificial intelligence or ML systems, then you will be able to increase the performance of your vehicle, okay. So these are the two layers which we can put upon IoT, so that you can avoid breakdown, you can also improve the performance of the vehicles. And another opportunity what in India we have is something called design. So far we were seeing about kind of an engineering, okay, kind of an engineering, like how to handle the systems, or how to integrate the systems. So for example, if you go in any expo with respect to EV or green energy, whatever it is, you could see many of the companies, they showcase the product in such a way that they are ready to integrate the technology. So for example, if you take Mahindra, okay, so let's say they buy battery from one vendor, okay, and let's say motor from another vendor. That's what you used to have. Finally, the vehicle is going to be Mahindra, but still, if you look at, I'm taking an example as Mahindra, but it is not going to be Mahindra. It can be applied to different vendors as well. So what is their opportunity as Mahindra or any X company? Their opportunity is to buy motors and different subsystems with the different vendors and try to integrate those systems, so that this integration will help the Indian customers in their point of view. Okay, so what Indian customers expects, let's say, Indian customer expects good mileage, long battery backup, right? Some kind of attractive dashboards. Okay, so some kind of comfortness inside the vehicle. So buying all these subsystems and integrate those subsystems and give comfortness to our customers is what a great business in our country. So the 1, 2, 3, 4 segments majorly play in that level. But the other systems, like other opportunities, like why don't we make our own products? So for example, if you look at an electric vehicle, we have a motor, and motor has something called a controller. That means controller is a electronics which actually powers the motor according to how you throttle the vehicle, right? So let's say you throttle the vehicle to 50%, the vehicle will go accordingly. But to give power to the motor, there is something called electronics called controller. So generally, we have seen many of the vendors, they try to manufacture motors, but very less people are manufacturing controllers, because the controller needs more intense knowledge, and it's really tough to develop such systems at very low cost. For example, if you look at a controller which is which we buy from China, let's say we'll get it for, let's say, for 10,000, for example. But if we develop, whether we'll be able to compete that cost. So that's the reason most of the people try to, because it's very difficult to meet the cost when we make in-house. So that's the reason many of the people go for the third party or imports. But although there are, if you look at Chinese products also, they are not good, right? So if you look at many of the controllers which we see in the third level of EV segments, like some of the companies apart from the tier 1 and tier 2, if you look at, there are tier 3 segments, and those segments we could see a lot of failures. So let's say in 1 year itself, you could see 3-4 failures in the vehicle. So these failures comes because of the adaptation of Chinese products into their mainstream. So why don't we make our product? So that's the question. We can make and we can compete in that cost. So only thing that we need to have such competency, and the market is really open to you. You can sell lakhs of controllers every year. The only thing that we should have some patience to develop the system, develop the controllers, and to compete in the market. So which is called battery development, okay, or we call it as algorithm development. We have also done a small algorithm where we try to imitate how the controller works. So it's a very huge space. People who are very much interested in design, okay, you wanted to do some own product, you need to code it, you need to integrate with hardware and so on, then you can think about model development. Okay, so model development is not very easy, but if you are able to make it successful, then I think you are the what you call kingmaker, something like that. So in India, we lack people who can develop such models, such products from scratch. And we have also seen many angel investors and fundraisers. They are very much interested to bring entrepreneurs in this segment. Yes, recently you would have seen Zoho. They have funded many companies, small companies, who can make power tools like your drilling machine. Those power tools an Indian company is making to compete with the Chinese products. So we wanted people who can work in that level, and that is possible today because the usage of AI tools. There are many AI tools which is there to support you, and with the help of those tools. And today, I don't think so. That's very difficult to make a product from scratch rather than doing service. Service is a great segment. Obviously, there is no doubt, but upon that level, the development, product development is also a very big stream. And next one, we have something called thermal systems. So battery pack thermal systems. So people are very much eager today, to expand their business from one place to another place. And if you, for example, you designed a battery pack in Tamil Nadu, and let's say it is working very good, and you wanted the same battery pack to send to, let's say, Kashmir or any other Canada, something like different countries where the temperature is very low. So now you don't know whether the battery is going to work, right? So these are the different challenges we have in making battery pack. A battery pack which works at one temperature condition may not work 100% to a different or lower temperature conditions. So how do we test it? Okay, this is a greater segment which we have in India. And another segment, if you look at, is called again how to develop motor algorithms. Okay, so that's what I have said. Again, this is one algorithm. This is also another different algorithms for different motors. Okay, so in electric vehicle, we normally use generally use PM-SM motor and BLDC motor. And normally, as I said, in commercial market, people try to buy controller from outside, but we can develop our own. Okay, and then we can make our own battery packs. This is something which we have seen in many parts of our country, but most of the places we couldn't see so much of success. Although Indian entrepreneurs, they import raw materials from China, okay, or they get raw materials within India, but the battery packs which is made by many people, we have not seen so much of success. The reason, again, the competency. So people have thought like battery is something, okay, you can connect plus and minus, something like that. It is not so. As I said initially, the way we deal these batteries, like lithium chemistries or the variants of lithium, like as I said, NMC or LFP, they are different. So engineers should understand the chemical properties and electrical properties of battery. And if you understand it properly, there's a huge opportunity that battery packs can be manufactured within India. Although we do it, right now we are doing it, but we couldn't see much success, because the reason is that I would have taken battery packs from 4 to 5 vendors. But whenever I go and meet those vendors, I could understand they're not technically so much competent. Although they have different machineries, they're very huge, planned and so on. But when you talk them technically, I felt that they're not so strong. So that means we have to learn so much, and before we enter into this. But if you people, when you come, when you come up as an engineer, and make sure that you can give more focus into the battery packs. Okay, so this is a very, very important technology which can create a lot of opportunities. And apart from that, there are other things. Other things means there's something called ECU, which is called electronic control unit. So electronic control unit means, so for example, you have a car, okay, and the car has different subsystems like motors. There will be heating, ventilation, air conditioning. There will be tire and other associated systems. There will be audio systems. Right? There will be security systems, safety systems, and so on. Now, all these systems are integrated. How do they talk to each other? For example, if there is a crash happened, okay, if there is a crash happened, suddenly airbag comes out, correct? Suddenly airbag comes out. So the idea is that how do they communicate to each other? That means the crash sensor and the airbag, how do they communicate to each other? Okay, so this is very important area. Today people are many people are dealing, even people like Robert Bosch, and they're also dealing all these things, which is called ECU, electronic control unit. So here in electronic control unit, you can connect all your subsystems, and all the subsystems can talk each other. Okay, but there are rules. Okay, there are rules, and based on the rules, each subsystem will talk to another subsystem. Okay, so that is what this ECU means. Let me show you some products in that area. Okay, so if you look at this one, okay, so you can see power windows. I just go with the basic system. One is called adaptive headlight. Okay, then there is a wiper control. There is a power window. Then your rear vehicle mirror. Then CAN-based VCU. We call this as the instrument cluster. Instrument cluster is nothing but your dashboard, where we have the vehicle control unit, the display. Now, the challenge over here is that each subsystem will be of different language. Like assume that like this. Let's say this is Japanese. There are 4 people who are from different countries. One is Japanese, Chinese, let's say Indian, and let's say American. So 4 different countries will be able to talk in 4 different languages. Okay. Now, but how do we, let's say if the Chinese guy wants to talk to Japanese guy, the Japanese guy doesn't understand Chinese, correct? So there is a problem. So similarly in vehicle, we have different subsystems, and each subsystem will be having its own protocol or own language. The language is commonly called as LIN, CAN, then such different languages are there. Most, so many. So how do they interact with each other? So for example, if adaptive headlight wants to talk to the instrument cluster, how does it talk? Okay, so this is a very broader area where India can work. Let me share that window. I think that window is not. One second, I'll share that window. Are you able to see that window?
Yes, sir.
Yeah. Okay. So, and if you press button, you could see your the rear mirror is actually moving towards you or away from you. How does it happen? Okay. And this is something which is communicated via different protocols, as I said, CAN, LIN, MOST, and so on. So this is one major area where people are focusing. Even big companies are focusing. And next we have something called software-defined vehicles. Let me show you some vehicle, a model vehicle. Okay, so here you can see, let's say when you open the door, okay, open the car door, we'll be able to, how we'll be able to detect. This is common actually, but many, not only, currently we have only few subsystems are connected in electronics. But currently, if you look at in EVs, we have many subsystems. You can see so many of wires are going here and there. Okay. And each subsystem can talk to another subsystem. So, for example, somebody opens the door, you'll be able to understand he has opened the door. Okay. And your engine starts, your engine don't start. So these are the subsystems in the vehicle. You can just watch the video. So there's a seat belt, which is a headlamp. So all are basically connected in the electronics. Okay, so now we open the door. Switched on the key. Now you'll be able to see, okay, on the VCU. Assume this is your VCU. So in this VCU, you'll be able to see whether the key is on, whether the door is open, all these things. So how it happens. Okay, so it's a very huge opportunity in India because, as I said earlier, we buy many parts from outside, but the integration part is what India does. India, in the strength of our country is more into integration. So when you wanted to do more in integration, you should know electronics. And then you need to know programming, a little bit of programming, and understanding of systems. That is also some basic competency you need so that you'll be able to develop all these integrations. So this is one thing. The second thing, one more thing I wanted to show you, how battery packs are made. So let me take one example. So this is what the battery management system, which normally we keep inside the battery pack. Basically, that helps you to protect the battery from overcurrent, overcharging, or over discharging. Okay, or any short circuit happens, because we have seen many failure in many battery packs. Because if this is the main brainchild. If this guy fails, then the battery pack will fail. So this is very important electronics. And so I wanted to show you how we integrate, or how battery packs are integrated within this BMS. So once you make the battery pack, these are the green colors are the cells, blue color are the cells, okay, lithium cells. And over the lithium cells, you can see some kind of square, okay, they are called nickel strips, which is used to connect each cells, okay. Then once you connect each cells, you'll be wiring those each cells, because if you look at the earlier technology like lead acid battery, which we have normally in our home, we are not monitoring each cell. There is only one battery pack. We will only monitor the complete battery pack, the battery pack alone. We are not focusing on each cell. But over here, the focus on each cell is very important, because if one cell goes bad, then the entire pack goes bad. So that's the reason all these red wires which you are seeing right now is the sensing of each cells. So once we sense each cell, then we try to connect to something called battery management system. Now this guy will allow charging of the battery and allow the discharging of the battery pack to the vehicle. And inside this is can be controlled through software also. Okay, so for example, you wanted to change anything. You want to say that, sir, I don't want current more than 10 ampere. Okay, I don't want current more than 20 amps. Now, how do I configure those systems? How do I set those systems? So right now, today we have the facility to, do configuration on our own. Okay, so for example, if you look at here, the current is written as 60 ampere of current. But you say that I'm making a vehicle where I wanted to give only 30 amps of current. So how do I control it? How do I configure the current limit? So that can be softwarely configurable. So whatever the product today we do, we are not making only hardware. So if you look at earlier days, some people will focus on the hardware alone. So today, hardware and software should go in the same hand. Then only we'll be able to give a futuristic products and the product which is more comfortable to the customer, right? So earlier days it is not so. Everything is hardware, and you need to get some people to get serviced, and so many things are very difficult. But today, we apart from the hardware, we also make a software so that people will be able to, monitor the things. People will be able to diagnose those hardware as well. Okay, so this is, so once we make the battery pack, we'll fit that BMS, and it's a brainchild of the battery pack, and then we apply. Then we can connect charger or motor or anything. So this is how the battery packs are made. And another thing which I wanted to show you is some softwares. So as I said, everyone today we are making hardwares, but it is equally important that you have to make software to monitor the parameters. That's very, very important, right? So for example, you give a hardware, what is happening inside hardware? How do our customers configure that hardware? How do the customers set their point of interest or the value of interest? So all these things are very important, equally important today. Okay, so that one example I'll show you right now. Let me share the screen. Okay. So hope you can see, we also made one software. So as I said, this is one hardware which we made, okay, which we made for the customer to test the battery pack at different temperatures. But this is not enough. As a company, it is not enough so that it give comfortness to the user. So to give more comfortness to the user, as I said, apart from or in addition to the hardware, you also need to support the customer with softwares. So most of the companies today, in addition to hardware, they have to give equal opportunity to develop softwares so that the user will be able to, enjoy the product. Right. So you can see here we have made a software, and in that software, whatever happens inside the pack or battery packs, you'll be able to monitor by sitting in the computer. Okay, so you can. So this is like an universal software, but that means the customer can add any point of interest which he wants to monitor. So this is something which you can also focus. But apart from hardware, this is very, very important segment which many of the companies are making. Because if you look at other companies, they have one company makes hardware and another company makes software, and that software may not be compatible with this hardware. So those interoperability can come. So to avoid that, these days the company who makes hardware, they're also making the software for the product. Okay, so that's how these things. So overall, if you look at the technology, what we understand in electric vehicle, there are more opportunities in making EV electric scooters, electric cars. So there are huge opportunity in vehicle design, chassis design, motor design, battery pack design. Then if somebody is interested, sir, I don't want all these motors and all, but I want to make some software. Should I study computer science? No. There are a huge opportunity that you can develop software in your core engineering itself, because we need so much of softwares today. Right? It is not like software means that you have to go to computer science, or it is like a domain of computer science. It is not so. Software is uniformly applied to all the products. So all the hardware products like electrical or electronics, any products, we need to develop software also. So people who there is a what do you call misunderstanding that I don't like hardware. So should I go for IT or should I go for CS? It is not so. There is huge opportunity for any engineers to work in the core engineering like ECE or EEE. You can still make a lot of softwares. Okay, and those competitions are now emerging. So suppose if you miss it for another 4 or 5 years, I don't think so we'll get a good opportunity for core engineers to make softwares, because many people are going to occupy this segment very soon. Right? So the opportunities are more into hardware, more into software, more into adding features, more into monitoring of fleet services, as I said, through IoT. You can also apply predictive maintenance. You can also apply AAML into core engineering, because core engineering has a lot of questions rather than the generic softwares or IT or CSE. Here we have a lot of problem statements to solve. Okay, so applying engineering skills in the sense, it doesn't mean that in the core you are going to work on hardware. It is not so at all. Okay, so there's a huge opportunity for many of the engineers. You can see even another 2 years, you could see these segments, these core segments is coming top one. There is no doubt at all. So with this note, I'm going to wind up my session. If you have any questions, you can ask.
Thank you, sir.
Thank you.
Participants, you can kindly unmute yourself for any queries, or you can post your queries also. Yeah, can raise your hand, or you can post your comment, or you can unmute yourself. And participants, I request all to complete the feedback link posted in the chat. Okay. Dear all, we have now come to the end of this wonderful event. On behalf of SA Engineering College, I would like to extend a heartfelt gratitude to our esteemed speaker, Mr. S.V. SREERAJ, for sharing such valuable insights with us today. Few to mention model-based EV battery, SOC and SOH estimation, battery thermal test chamber, model control algorithm development unit, battery pack assembling, and video of the real-time working models. And he has also given some information regarding the opportunities for EEE and ECE students. The session was very informative and useful, sir. Thank you. Thank you very much, sir.
Thank you. Thank you so much.
I also want to express a special thank to our organizing committee who made this event possible. Finally, thank you all for being here, participating, and making this event successful. We look forward to see you at our next event. Thank you. Thank you very much.
Can I leave, ma'am?